1, go.
All right. What was my hint? Let me get back to actually my notes. It's over.
Oh, number 3.
I should write down something.
There's one more example. Let's go and check it real fast. All right, guys. Come on, let's focus on it. For better or for worse, right now, just focus on math, whatever is going on in life. Okay, let's focus on math and try to get it down.
Okay.
Okay? Here we are in section 7.1. Some of you guys, hopefully, all of you, already wrote the top. And the top says, adding and subtracting polynomials. Everyone say it with me. How do you say that word?
Polynomials.
Okay. In geometry, not geometry, in your earlier math classes, have you guys ever heard of polygons?
Yes. Yeah.
Yeah, polygons.
Five.
Poly is an English prefix meaning many. Pentagon, pent means 5, right?
Oh.
Dodecagon means 12, and you might not learn that one. Triangle, deca means 10. Dodeca means 12.
Oh, I know.
No, you're okay. Triangle, tri has 3 sides. Rectangle is kind of, I don't know. Now,
Very good.
Alan, hold on. Ian. Oh, adding and subtracting polynomials. So many what? Well, we'll figure it out today. Okay? Jack and Aiden. Aiden, just go ahead and move up one today. Just to try to help you stay focused, okay? Okay, it's okay. We're going over it now, though. Here we go. Adding and subtracting polynomials. Poly means many. We'll get back to as to what's it talking about, many. But first of all, this is a review. My hint to you was, and I already said it a little bit earlier, combine.
Like
Means
terms.
like put together, right? Like terms. Have you guys heard that before?
Like
Oh, yeah.
variables.
But that doesn't mean, just because we've heard it, that doesn't mean we've mastered it. And I've seen probably at least a third to a half of you make mistakes on this review concept, okay? So I need you guys to think about the following before we do any of this work. Got it? I need you to think about the following. What if I was to give you, over here to the side, let's just get rid of all the math, all the variables. Give me 1 second. Just because I've seen this mistake copied or repeated so many times, I want you to think about, what if we had 6 apples plus, undo,
Again.
plus, what else do we have?
5 oranges.
5
$3
Okay.
minus 4 apples. We'll do 3 apples. I'm just trying to make it match. Minus 3 apples plus $4. Now you don't have to write this down if you don't want to. I just want to go ahead and show you how algebra really isn't that crazy, and actually even kindergartners, yeah, I'm going to go ahead and make it match so it matches perfectly. Do you guys see where I got my 6 and positive 5 and negative 3 and negative 4?
Oh yeah.
Okay, now hold on, let's get rid of all the variables.
stuff.
Technically, kindergartners can learn algebra. As long as they know how to add and subtract. So maybe not kindergartners, maybe like first or second graders. As long as they know how to add and subtract, they can do algebra. And here's what you could do. And if you know anybody who's younger, anybody have like younger siblings or younger like nieces, nephews?
Very dark noises.
Now hold on. Now, you have to maybe start really simple. I want you guys, if you know anybody who's little, over the next, I don't know, week or so, do this test with them. There was this TED Talk. Has anybody heard of TED Talk?
Yes.
Anyway, there was this TED Talk. This TED Talk where this really smart guy got up and basically said, algebra is not meant to be hard. It's not meant to be hard, but it becomes hard because sometimes we throw those X's at people and X squareds and all this crazy stuff and people get confused. He said, you know what, I had this like 6-year-old niece and I taught her how to do algebra. And here's what he said. He told her, ready, eyes on me, just take it off the board for a second. He told her, if you have 2 apples and you add another 2 apples, how many apples do you have? What do you think she said? 4 apples. Then he was like, okay, what if you have 2 oranges and you add another 2 oranges? What do you have? What do you think she said? 4 oranges. Then he said, okay, what if you have $2 and you add $2 more? What do you say?
You're dumb.
$4.
swear, Rob.
Now wait.
He's so dumb.
The next thing he said was, okay, so what if you have 2x plus 2x? What do you think she said?
4x.
Dang, she kind of smart.
Wait. Algebra is not meant to be hard, right? 2 apples plus 2 apples is 4 apples, right?
Oh, right.
2 oranges plus 2 oranges is 4
Oh, you
oranges.
said six.
$2 plus $2 is $4. So 2x plus 2x is 4x. It's not meant to be harder than that. With adding and subtracting, when does it kind of get hard?
You start adding.
Multiplying, dividing, exponents. Okay, so hold on. Eyes back to the front. So if you had this example, 6 apples plus $5 minus 3 apples minus $4, what do you have all together, guys?
Three apples and 1 dollar.
3 apples.
3 apples and
$1.
$1.
$1.
Okay.
Plus $1.
Now, why didn't you guys just tell me 4? Why would you? These are apples and that's $1. They don't go together, right? They're not like terms. We only combine like terms. So, if we take the algebra that you guys are supposed to do, let's just make sure that you knew what like terms were. And I'm going to, just to make sure that we're not making silly mistakes, I'm going to use a simple property. Alan, I need the noises to cease. I'm going to go ahead and use this cool property with addition and subtraction that says I can rearrange things. You ready? I'm going to put 6x, the negative 3x first, the 5, and then the negative 4. Now guys, did I change what's up there? Look at the front. Did I change what's there?
No.
I just changed the order.
Wow.
Oh.
Now why did I change the order? Because
To make
then we
everything
can say,
easier.
yeah,
Interesting.
6x minus 3x. Don't we add and
Stay
subtract
tuned,
from
my
left to right?
Yep.
6x minus 3x is what?
3x.
3x.
Got it.
Plus
1.
Now I just rearranged things. The negative had to go with the 3 if you guys want to see it. If you want to see it, the negative goes with the 3. Subtraction is adding a negative. The positive had to go with the 5. The negative had to go with the 4. So 6x minus 3x, are they like terms? Yes. So 6x minus 3x is 3x. Now, plus 5 minus 4 is 1. Now, why don't I put those together anymore?
You can't. You're not.
They're different. They're not alike. So we just box it and say done. Right?
If it was 1x,
I got x equals 1.
Now, could we also write 1 plus 3x and still be right?
No.
Yeah.
Doesn't it mean the same thing? It means the same thing. It's actually not in what we call standard form that we'll learn today.
But you want it.
We usually,
Terms supposed to be the third.
yeah, we like the number by itself, which we would call the constant. We like the constant by itself at the very end. And we like x terms before the constant. So, we'll talk about that more today. Don't worry. Yes.
That's what I was.
Now, number 2, hold on. Before we can rearrange, guys, what do we have to do? PEMDAS dictates.
Please excuse my dear.
Yeah, please excuse my dear and Sally.
Please excuse
Wait.
my dear
Josh, it's already been said. We're wasting time. Eyes at the front. Please excuse my dear and Sally needs. Try to do anything in key, please. Parentheses first. Now, can we put these together? Y and 3? No, they're different, right? So we can't do parentheses. We move on to please excuse. Exponents, there are none. Not them. Then we move on to multiplication division. Do we
That's
have any
distribute.
multiplication division?
Yes.
Yes.
Negative 8y minus. Wait.
Okay.
No. Plus 20.
So wait. Let's just say we did multiply the negative 8 in, right? So we have multiplying. Negative 8 times y is?
8 negative 8y
Good.
plus 24.
But let me go ahead and show the order of this. So that's the first distribution. Negative 8 times y. Every time you draw an arrow, you multiply. That's negative 8y. Now what's negative 8 times? If you don't like the negative, you gotta make, if you don't like the subtraction, make it plus a negative. What's negative 8 times negative 3?
24.
Careful. Positive 24.
Yeah,
We
20
have to put that sign, okay? The plus.
plus
Oh.
Does that make sense?
plus 2.
And then the plus 2y is not in parentheses, so he remains. Now, if you would like, if it makes it easier on you, you can rearrange this to put the y's next to each other.
But you wouldn't make this a negative because there's no equals.
Exactly. The positive goes with the 2. There's no equals. We're not subtracting anything. We're just combining. There's no equal sign. We're just putting them together. So now read it. Negative 8y plus 2y is,
24. So that's negative 6.
and why don't I do anything else with the 24?
Because it's not like
Because they're different. Does that make sense?
Oh.
Yeah.
Justin.
That's only if there's an equal.
Okay, wait. I think Justin's question.
For me, I didn't there. I subtracted 24, so it would be negative 6x.
Now wait. Any of you that go any further, this is not a solving the equation problem. Let me show you what that would look like
Because
and
there's
why
no
this
equals.
isn't one. If there was an equals, look Justin at the front. If there was an equals on the other side, then we would keep going to solve for x. But question, were there any equals on the other side?
No.
So
So you
we
just
just say
solve.
we have simplified until we cannot put together anything else. They are not like terms, so we stop. The directions were simplify, not solve, and there is no equal sign. Does that make sense?
Yeah.
Now, number 3, we're going to do all together. Some of you have seen it, but most of you haven't because it was kind of hidden at the beginning. What would we have to, don't tell me the answer, I don't want to know it. What would we have to do first? Can we put parentheses? Can we put either of these together?
4h plus
Wait, I want to hear the answer. My question. Can h plus 6 go together?
No.
No. Can h minus 2 go together?
No.
So parentheses are out. Exponents. I don't have any unique ones. So then multiply, divide. Do I have multiplication, division, Josh?
Yes. Well,
Okay. Tell me what it is. Where's the multiplication?
you distribute the property.
Yes, I have the 4 on the outside of h plus 6. So when I bring the 4 in, what do I get first?
4h
Put the plus sign. 4
plus
times 6.
24.
Now, here's where it gets tricky. I have it to the front. Why are we watching each other? Jay, you're distracting people around you. What you're doing with your hands is distracting. Make sure you're focused at the front, okay? Do you guys see parentheses over here as well?
Yes.
There's no number in front, which means there's an understood what?
1.
Whenever we don't have a number in front, there's an understood 1.
Distribute.
Now, subtraction is adding a negative. There is a negative 1 in front of this expression that I have to distribute. What's a negative times a negative?
Positive.
Oh, I got it right. Yes.
Now let me go through that one last time. It's kind of hard to see, and this is where a lot of kids make mistakes. For the second pair of parentheses, there's a negative 1. Subtraction is adding a negative. There's a
Why?
negative 1 in front.
But why?
Because subtraction is adding a negative. Subtraction means taking away. Negative means taking away. Does that make sense?
Yes.
Let's do it. Why did you change that the subtraction in the middle to a
I'm changing it to adding a negative because the definition of
It's just-
subtraction is adding a negative number. Okay? So
But
when
if you were to leave it, it'd just be -1 minus 2, which is two negatives.
so take the negative on the
The whole
inside. Negative has to go with the h.
Yeah, it's distributed. So pretend like there's a -1 right there.
And negative has to go with a -2, which is a +2.
But that's only if there's parentheses.
So Alan, there's a negative on the outside.
Oh, I thought that whole h plus 2 went away. That's how I was so
Oh, no.
confused.
I was going back to go through it one more time.
Oh, okay. No,
I was going back
understand
to go
that.
through it one more time. So the negative has to go with the h, and the negative has to go with the -2, which makes it a plus.
But why?
Yeah.
Why? Well, like obviously, multiply by minus. I don't know.
Because we technically can't multiply by a negative, but we can multiply by a -1.
So is that multiply by.
Long story short, Diego, does it make sense why I have -h plus 2 up there? Does that make sense? Okay, you're okay. You're good. So then let's go ahead and keep going. Guys, do you see any things that we can combine?
Yes.
Now, can we try to skip a step and can we look at what's in common, right?
Common.
And what's in common?
The negative, well, the H.
Now be careful, the 4H is going to be plus or minus the
Minus.
other H.
Minus
Good, so we're going to end up with how many H's?
3H.
Good. The 24, positive 24, is going to be plus 2 or minus 2?
Plus 2.
Now, can we put those two together?
Yes, sir.
No. Are they like?
Are
3H
different.
and 26 are different,
Because
so they
you put
have
them
to
together.
stay. We keep them together, but we can't add them anymore.
Yes, sir.
Does that make sense? We can't combine anymore. Jazzy,
Where did you get the 3H from?
do you see the purple underlines? I noticed that the 4H and the negative H were like terms, like apples with apples. So if I have 4H minus or take away H, I have 3H. Does that make sense? Remember, there's always an understood 1 in front. So then if it helps, 4H minus 1. Does that make sense? Yeah. Alright, kiddos, that was our warm-up. It's a really important warm-up for chapter 7. We're going to do a lot more with adding and subtracting and combining like terms. But for right now, we have to take some time to talk about polynomials. What is that? Well, let's start with not poly, not many, but monomial, which is one.
Should we write this down?
Mono.
Yep. Notes, 1 for 1. Not mono as in hand, but mono, M-O-N-O, means 1. Josh, you should be ready.
I should.
You should. Monomial. Before we can get to polynomials, we need to write about a monomial. So monomial. Who is he?
Mono.
Monomial. Who is he? Well, here's what it is.
It's 1.
It's a number. Monomial. It's a number. Or it's a variable. Or it's a product of numbers and variables together. Now, hold on. I see a math word. Do you guys see a math word?
I do.
I see product, yeah? Okay, hold on. Let's review real fast. When you hear product in math, it's not sum, it's not
Multiply.
difference. It's talking about multiplication, right? Just in case you need to remind yourself. It's multiplication, yeah? So in case you need to go ahead and tell yourself what a product is. A monomial is a number, or a variable, or a product, a multiplication of numbers and variables. But you guys should also write down the little note below. What is it not?
Not addition or subtraction.
A monomial has no addition and it has no subtraction. Okay, I'll show you why. It's just a fact for right now. Now I'm going to put a few things down below and I want you guys to think through, don't say it out loud, but think through which of the following are monomials. If monomials are numbers, variables, or products. Now don't say anything. Don't say anything. Circle as many as are true. Guys, the noises are not acceptable. A monomial is either a number, a variable, or a product, multiplication of numbers and variables. Doesn't say how many. One number, one variable, or a product, multiplication of numbers and variables. I want you guys to go ahead and after you write them down, circle any of the ones you think are monomials.
Monomial.
Circle monomials. Like polynomials, monomials. moment about 34 being a yes or a no, and I'm looking for someone to raise their hand to give me the yes or the no and why. Angel, what do you think about A? Why? Exactly.
Good job.
You guys can circle A. It's a monomial.
Oh.
Because my brother's name is Barry.
Okay, wait. So Angel is right. A is yes. Why? Because it's a number, and it says monomial is a number. Cool. Okay, who can say B, yes or no, and why? B, yes or no, and why? Diego. Wait. The question is it a monomial, yes or no, and why? No. Why? There's a number and there is a variable, and what's going on in between them, Kaylee? Addition. Are we allowed to have addition for monomials? No. So nope, A is a no. So far we have A as a yes, B as a no, C. You can tell me yes or no and why.
Opa.
Jackson. Yes, why? It's a number and it's a variable, but what's the operation? Multiplication. Are we allowed to have multiplication?
C.
Yeah. Of course we are. Okay, letter D. Yes or no and why? Jazzy. Exactly. The subtraction says no and the addition says no. Good job. And then letter E. That's a little bit more exciting. Rob, you want to take it? Go for it. Normal voice.
If it's a monomial or not?
Yeah.
It is not.
How come?
I'm using my gut.
Okay, so Rob's looking at it like, wait, that looks way too complicated. No way is it? Does anybody agree or disagree?
I agree.
Jay, what do you think?
I disagree.
Okay, disagree. What do you think it is? It doesn't have adding or subtracting, even though it's complicated? The answer would be yes. Now guys, that's a common mistake what Rob did.
Oh, that's a negative number?
Listen.
Wait, what? I tried.
I thought it was subtraction.
Guys, hold on. 5 times n squared times n to the 4th times key. That's all multiplication.
All multiplication.
So it has numbers and it has variables with multiplication. Even though it looks complicated, yeah, it's a monomial. Now hold on, I have one more to ask you, and let me see if I can trick you guys. You ready? Let me see if I can trick you guys. What if I have one more?
I already know the answer.
And what if I put 3 m cubed over 4?
No.
Oh, it is.
3 m cubed over 4. How many of you guys think yes? How many of you guys think no?
I think yes.
I'm gonna actually tell you guys whatever this one is not. Hold on. One of these is yes, and one of these is no. This gets a little tricky. One of these is yes, and one of these is no. Okay? Now hold on. Let me go ahead and actually show you a different way of writing this one. I could write this as 3/4 m cubed. If I divide by 4, I can take the 3 and the 4 and put them together. 3/4 m cubed. Now, does that help anybody decide which one is yes and which one is
Yes.
no?
Yes. I did it.
Alright, Jay, what do you think?
I think the first one's yes, but the second one, if you do, I might be wrong, but the second one, because it's 3/4 plus 1/m.
No, there's no addition. There's no addition. I agree with you. This one is the yes. That's true.
Yes.
This one is the yes. Jackson, why?
Just because for the G, it's because you're subtracting with your
You're not actually subtracting.
it's going to be a negative.
You're thinking it's a negative exponent. That's actually really good, Jackson. But let me try to reword the actual reason why. Ready? In letter F, question. What is 3/4? Isn't that a number?
Yes, it is.
What is m cubed?
It is
It's a variable expression. What's going on in between? Multiplication. Question. if I was to rewrite this guy as best I could, am I multiplying by the variable or by 1 over the variable?
I went over the variable.
I'm still dividing, right? I'm still dividing by the n cubed. So therefore, in letter G, since I can't change this division, since n cubed is stuck below, I have to say no. This may be a little bit more complicated than you guys have to know.
Whoa.
But I want to show you the difference between yes or no with division. If you can rewrite it as a number with a variable, you're good. It's a yes. If, when you try to rewrite it, the variable is still being divided or in the denominator, it's a no. Angel.
So like let's say a bigger problem, we actually have to solve it to figure out whether
Yeah. Yeah, which is why we were studying those things with exponents, because we have to simplify first to be able to know what's going on before we can know if it works or not. So, ready? If the variable can end up on top, we can call it a monomial. If the variable ends up on the bottom, we have to say it fails. Because it's like division if it's on the bottom. If it's on the top, we can say, oh, it's multiplication.
So that wasn't.
This one was just division in the number, it wasn't division in the variable. Does that make sense?
True that.
We'll keep practicing, don't worry. Now, here's the second big idea. We have basically 3 big ideas, and the last one is the longest. We gotta hang in there today, okay?
Degree.
Degree is the second big idea. Degree is the second big idea.
Degree.
Now, you guys write quietly, and let's see if we can multitask a little bit.
Let's.
Degree. Degree.
What's a degree?
We've seen degrees, or you guys have heard degrees in other cases, like, what's the temperature outside? I don't know, about
or your
72
degree, like
degrees,
master's degree.
right? Or when you go to college, you get like a bachelor's degree or a master's degree. Or you could also hear it in just normal everyday language if you're talking about something to the effect of, to what degree was the crime, or to what degree, it kind of means the amount, or it kind of means the strength, or it kind of means the magnitude. Yeah, like the level, that's a good idea.
Insane.
Like when we talk about the magnitude of an earthquake, we're kind of talking about its degree, how strong it is, okay? When you're out there in the weight room, some of you got athletes, and you're trying to like figure out how much you're able to lift, or how much you're able to curl, or how much you're able to, you're kind of trying to figure out your degree, to what degree can you lift, right? Degrees and angles, that's kind of more of a measurement, but you're still trying to figure out how great is the angle. You can think of it that way. Now, in the description, the degree of a monomial, which right away, all 3 of these or all 4 of these are monomials, okay? I haven't tricked you at all. All 4 of these are monomials. We say the degree of a monomial is the sum of the exponents of the variables. I do not say of the numbers, okay? The sum of the exponents of the variables. Now, sum, that's a math word. What's it mean? Yeah, the addition, right? So we're adding together all the exponents, true? So kiddos, in letter A, you have to first identify where is the variable, and here he is, right?
Yeah.
Okay. So then if that's the only variable, then what is his exponent? The degree is 2. D, remember how we had that for common difference? I don't like that, but you could do DEG for degree. Does that sound good? You can call it a second degree. I think they'd be polynomials.
Degree
They
20,000.
could call it a second degree. You can think about like murder in the first degree, second degree. You can think of this as a second degree polynomial. That's how strong it is. Now, this might make a little more sense when you go look at these exponents. Okay, look at letter B. I mean, making a ruckus. Make sure folks do that. We're good. Eyes open.
Ow.
Have I already highlighted the variables in letter B? Yeah. Now hold on, wait. In those variables, y has a power of 3. It's going to focus in. Y has a power of 3. What does x have as its power? Good. Some of you would forget that. But y has a power of 3.
Anything
Oh,
without
because
the
any
power
single
is-
one.
Because we could write this as x times y times y times y, right?
Yes.
So if we add together all the exponents, then question, kiddos, what would be the degree of this one if we're adding together the exponents of just the variables? Yeah. Degree equals
What?
4. Take the degrees of the variables, take the exponents of the variables, and add them together. 1 plus 3 is 4. Okay. That's it. So then you guys, go ahead and tell me, don't say it out loud. Find me the degree of C.
I understand number 8.
No, C. Find the degree of C.
C.
I'm going to start highlighting. Some of you are already saying it. Do we all agree it's 6? Now, hold on. Some people are already starting to do D because they're like, wait, I got this. And they're like,
One.
No, D is
Zero.
No, it's one because it can't be
zero.
well,
anything that is 0 plus 1.
this gets tricky. 0 or 1, that's kind of the debate. And it'd be the debate in almost any algebra class around the nation, okay? Ready? Here we go. If there's no
I have
x, what would be its exponent? Would it be
One.
1 or would it be 0?
One.
There's no x.
One.
Zero.
There's no x, guys. Its exponent would be 0. If there was 3x to the 1, that would look like 3x, but what was there to begin with?
3.
There was no x, right?
So
So we have to say this is the same thing as x to the 0. They don't have to write it, but you have to see it. There
One.
is no x, so its degree, what's the exponent?
One.
0.
Oh yeah, 0.
If it was 1, there should have been an x. There is no x, so the degree is 0. The variables have no power. They're not even there. Does that make sense? The variables have no power. They're not even there.
Will the variables change? Like, will it always be x and y, or is it be x and
It could be something else. Do you want us to do one more with something else?
yeah?
Okay. So what if, that was a good question, Angel. Okay. Remember the noises next time. What if I was to do something like 16 squared n cubed n p squared? It's okay.
That's not right.
We can do the tough ones, we can do the easy ones, right? Where are the variables? Where are the variables?
20 variables.
Where are the variables?
Well, first you have to add all the variables together.
3 plus 2 is definitely 5.
And then remember the
Plus 6.
Add 1.
Where are the
Jordan.
variables?
Oh, 16 squared, that doesn't count as
It's almost 5.
Yes.
It's not 7, it's not 8, it's not 5.
It's 6.
Why?
6.
N is to the power of
Yeah.
Come on,
Of
One.
zero. Oh.
Y equals 8.
Never mind.
3 plus 1 plus 2. Why? Listen.
16 is not a variable.
Singular.
16 is not a variable. I was trying to
Just like
trick you. You only look at the variables. I tried to trick you with n to the first power as well. Barry, let me see your notes real quick.
Didn't bring mine today.
Okay. So I'm going to check them tomorrow. And if you don't have them ready, my advice is, and I'm going to try to help you with it, is make sure you borrow a piece of paper every time you forget, okay?
Good.
All right, so 3 plus 1 plus 2 is 6. Good?
Yes.
So degrees of a monomial. Add together all the exponents of its variables. Now guys, we've covered monomials pretty much in as much depth as we need to for now.
Wait.
The title of the section was polynomials. We're ready to build. Okay, ready?
Wait.
Monomials are like little bricks. They're like little blocks. It's no fun just to play with one block, right? We want to play with a lot of them and build them up.
Yeah, let's
I like
start
Legos.
building up.
Lego.
I like Lego.
Let's start building up. Let's start building the polynomials. And as you guys are writing, let me show you some examples of polynomials. No. Word for word, important. Everything's important. Polynomials. Like polygon, polynomials. Usually you don't say it like an E though. It's like usually polynomials. Either way.
I say home.
Poly works. I'll take it. Polynomials.
Polydactyl.
Okay.
was about to say that.
A polynomial is a monomial, could be one, or a sum and or difference of monomials. So it could just be one, or it could be a sum and difference of several. Sum or difference, remember sum, just quick review. He's adding, right? Difference, what is he? Subtracting. Not positive,
Is
negative, adding, subtracting.
Is that dinomial?
It's binomial.
Binomial.
It's hard to see.
Oh yeah, I kinda got stuck in that.
I thought I put a D. What happened?
Don't worry, I'll zoom in.
It just looks like
Monomial?
Binomial.
It looks like a D.
Binomial. Trinomial.
Oh, it's a big D.
Alright, add in a minute.
Oh, very.
Okay, let me try to show you guys some examples, okay?
It could be in
Trinomial.
Okay, I've written examples down, right?
Sure.
Okay.
Hey,
Barry, you can go ahead and go now since we're Okay, hold on, wait. Can you guys figure out, Mr. Kim, go ahead and go. Polynomial.
Hold on. See you on the flip side.
Alright, you gotta quiet down, let's
I'm
not
ready,
another
Barry.
minute. We're still at one, don't make it two. Monomial or some difference of monomials. Why do you think binomial, bi, English prefix for two, bimodal,
Bicycle.
bicycle. Okay, unicycle, right, and a bicycle. Okay, there's many more examples, but for right now, binomial is two terms. What do I mean by terms?
Turn?
How many monomials are there in this expression? Two.
Oh,
Terms are separated by plus or minus. So it's not a monomial, there are two. So it's a binomial. How about the next example? How many are there?
Two.
Three. So it's called a trinomial. Now, could there be 4 or 5 or 6? Yes. Okay, hold on.
Oh, wow.
The names come from how many monomials there are. If there's only one, just a monomial. If there's two, binomial. If there's three, trinomial.
Is that first one say binomial?
Yeah, binomial.
Oh,
If
I
there's
was
four.
thinking of the
So
degree.
don't
I was
look at
thinking of
the
degree.
sign.
Man, you
Look
stupid.
at the pieces. Okay? Look at the signs. The plus or minuses, they're separators. We have to look at what's in between. So, there's one addition, but there are two terms. There's one addition, one subtraction, but there are three terms. Now, let's go back.
Oh, nice.
Binomials and trinomials. Now, hold on. We have two more big pieces to talk about. Once you have polynomials, which are a collection of terms, could be 1 or 2 or 3 or more. Now, some of you are like, well, hold on, is there a special name for 4? Actually, no. Once we go to 4 or 5 or 6 terms, we can count them, but we just say polynomial. We only have special names for monomial 1, binomial 2, trinomial 3, and then the rest are we just use polynomials, yeah. To find the degree of a polynomial, the answer is the highest degree of its individual terms. The highest degree of its individual terms. We'll talk more about this one tomorrow. But the highest degree of its terms, here's what's going on, kiddos. We say the number or the degree of the winner. It's the degree of the winner. What do I mean by that? If there's more than one term, then we have to take the degree of each of them, and we keep the winner's degree. We don't add them all up. We take the winner's degree. And the last little piece you guys need to write down, standard form. Jordan referred to this earlier. We go in decreasing order one little hint is the number alone or the constant alone, the number alone goes last. The number alone goes last. Now we do have some examples that we have to look at before we leave. We're still staying an extra minute after. If you guys focus, I'll try to get you out by that minute after, okay? Number alone goes last. You can write down these notes tomorrow. I'll have them on the screen at the first or at the beginning of class. For right now, let's go ahead and do at least one example. I would like to do 2, all right? The very first thing, hold on, the very first thing that it asks us to do in the directions is write the polynomial in standard form. Now I just said standard form means the number last. The highest degree first. So question, kiddos, in the first one, where should the 4 go? The 4 should go last.
Yes.
Now what sign was in front of the 4?
A positive.
So there needs to be a plus.
It's
The
negative
9z is going to go first, but
Neg-
what sign was before it?
Negative.
A negative.
Negative 9z plus 4.
Okay? Now we're just following the first direction of writing the polynomial in standard form. For number 6, who should go first?
The one with the number.
No.
The highest exponent.
The
Oh, the
highest
highest
exponent, which
Oh, I remember this. I remember
is
this.
t cubed. What sign does he have? T cubed. What sign does he have before
Negative.
him? Negative. Who should go next?
Plus t to t
T
squared.
squared, and the sign in front of him is a positive,
And then minus 10t.
10t should go last with a negative. We always put the highest degree or exponent first going down. I'm going to give you one more minute. Because we have to talk about degree, leading coefficient, and classify. Don't worry, we got this. The degree. Question, who's the winner of the first problem, number 5? Who's the winner, 9z or 4? Who has more variables?
9z.
Okay.
Negative 9.
What is the exponent of all the variables in 9z?
1.
Yep, so the degree equals 1. Looking at the second one. The winner is the first one, right?
Yeah.
What's his degree? What's his exponent of the winner? 3.
Wait.
Hold on. Leading
Oh,
coefficient.
okay.
What is the number of the first term? What's the leader? What number is in the very front? Leading coefficient is negative 9. What's the leading number in number 6? No, the leading number, the beginning number.
Negative 1.
Negative 1. And the last thing you need to know is how many terms in number 5? 2. So what are we going to call him?
Binomial.
And how many terms in number
Trinomial.
6?
Trinomial.
3. So we call him a trinomial.
House.
There are a lot of ideas, but the work is not hard. You guys need to take a picture of homework. This will be on the video if you guys want to go watch the video again for these last few examples. Try the best you can on 5 through 20 all. Take a picture and you may leave. Bye guys. Take a picture and you may leave. See you later. No. Eating is first. So which one is first?
God.
What is last?
Ah.
See Papa.
Come here, toilet.
That means that toilet.
Come here, toilet, brother. Come here, give Papa. Come on, toilet, brother.
I saw someone look in my box and I got one, but I just got it right on my neck.
I got it in your shirt. Dude, I thought I got you in the neck.
Is this still in my shirt?